All right, welcome back. And today we are going to look at a linked list question. It is called rotate linked list. So given a linked list and a number k, rotate the linked list by k places. All right, cool. So here's the code for what a node is. And then basically what we want to do is we want to be able to rotate a list by k places. And remember, k can be actually bigger than the linked list length, but it's pretty easy to like solve this issue. We can just modulate it, but we'll show you later how to do that. Now, let's look at the drawing real quick. Now, what we have here is a bunch of k's, right? So I just want to show an example what it would look like. You know, k0 would be this, and then k1 would look like that. K2 would look like this. So basically the yellow part is the one that that kind of moved. And we could add another one, which would be k4, but k4 would basically be the same thing as this guy. So k4, 5, because it just modulates, right? 6, 7, right? These would be essentially the same thing because you would just do a full rotation. Okay, so I think what's interesting here is you could see if k equals 1, then only the last k number has been rotated, right? And then the same thing for 2. If it's 2, then it's these guys, and I kind of marked it as yellow, right? So then it's only the last k elements that will be moved and put into the end. Essentially, that is quite a simple problem now that we break it down like that, because we could also think of rotating one step every way depending on how many k. You just redo that many times, but that would be extremely inefficient, and it would be kind of a like almost as if an n squared algorithm. Because each time you rotate, you might take the whole array to go find the last one and then go point it to the next. So it'll be n squared. So that would be inefficient. So what we can do is we understand that given the number k and we modulate this by 4, then we know that we're going to be getting the last k elements that we need to move. So let's do an example here. If we look at this linked list. I drew it so that it's a lot easier to see. And then imagine if k equals 2. So that means we care about these elements now. Right? We care about 4 and 5. Okay. And then what we want to do is we want to move them to the other side. So let me show you exactly what you have to change to achieve that. We're going to draw in red for all the changes that we'll make. So what we want to do is we want to turn 1, 2, 3, 4, 5 into 4, 5, 1, 2, 3, correct? Yeah, so how we do that is we want this guy to be the head, right? And then this guy, we want this, instead of pointing to null right now, we want it to point it to the head, the old head. Okay, so then what else do we need? So we want this to be the new head. We want 5 to point to the new, to the old head. And then what we want to do is we want to cancel this guy. We want this guy to become null. So there's 3 changes that we need. And how many pointers do we need for that? Well, we need to be able to access this guy. We need to be able to access this guy, and then the front, and also the one beforehand. Cool. So that makes sense. So how do we do that? So here we have the same list, and then this time I will show you 2 pointers. We could use 2 pointers to access all of these guys. So we're gonna have it's kind of 3 pointers because we have this guy, which is the head anyways. So here we'll call this guy head. All right, and then we'll also have, we'll also have a slow pointer, and we'll also have a fast pointer. Okay, So what we want to do is, given that k equals 2, then we want the pointer to go k times first. So 1 and then 2. All right. And then after we've gone 2 already, what we want to do is we want to move the slow and the fast pointer at the same time. And what that would look like is this. So 1, 2, and then k has reached the end. All right. So now we have the pointer here, a pointer at fast, and then what we want to do is we want to do this operation. Let's see. We want to do fast dot next equals the old head. Okay. Actually, let me rename this to list so that it's gonna be the same as when we're gonna code it. So we're gonna name that to list. So what we can do, fast dot next. So fast dot next equals list. So we're gonna do that. This is what's gonna do. So exactly like what we did previously on this example. So we got this, and then next, what should we do? We can do. Oh, actually, we'll have the. And then what we're gonna do next is we're gonna have a new variable called, let's see, let's take another color. Let's take this one. We're gonna call head equals to slow dot next. So what is slow's next? It's this guy. All right. So head equals to slow's next. So it's this guy here. And then there you go. We have head here. This is perfect. And then what's the last thing we want to do? We want to take this out. So what we want to do at last is slow dot next equals null. And what that would do, it would destroy this and it will become null. And then basically this is the same as what we had previously here. So that's how you do it. And then now if you go through the array, the linked list, the head would be here. So you have 4, 5, and then 5 connects to 1, and then 2 and 3. And then there you have it. That is a rotated list. Now, what is the time complexity of that? The time complexity is linear because you have to go through the array, like the fast pointer has to go through array and the slow pointer also, so that's linear. And then space complexity is constant because it did not change at all. We didn't add any new space, like new arrays or anything. So the next thing is, remember, what if k is like too big? Well, the only thing we need to do is we modulate it, right? Kind of like here. We just modulate by 4 and we're gonna get a k that is in between 0 and 3. And then we do the same thing here with the new k, and then that's pretty much it. All right, awesome. So yeah, that's pretty much it. Now let's just code it up. All right, so first what we wanna do, the reason why we modulate it by 4 is because that's the length. So we have to modulate k by the length. So first, let's just get the length. And to get the length, you have to go through the whole array. So let's just go through the whole array. Current length plus 1. All right, and then current equals current next. So this, what it does, it just goes through the whole array until it stops. So then it gets the length. And now let's get the special k. We'll modulate it because we don't care if it's like bigger than the length, then we'll just modulate it. All right, so now that we have k, what we're gonna do is we're gonna get the fast array and the slow array. So they're both at the head of this list. And then what we're gonna do is first we're gonna move the fast array, right, by k, fast.next. And then, well, fast.next is not none. All right, cool. And then now in this while loop, we're gonna move both of them. And then we'll stop once fast hits the last node. So fast equals fast.next and slow equals slow.next. And then once we stop and we're done, we do that 3 operations that we wrote before on the iPad, right? We have this slow.next, head.next. So we just rewrite those, but in code form. So fast.next equals list, and then head equals slow.next, slow.next equals none, and we return head. So let's see if this works. All right, perfect. So this is basically the string version of the list. We might be able to make it a little bit more aesthetic. Okay, let's see. Okay, cool. So yeah, so if the pointer at the end, it means it's a null pointer. So here we have the list 1, 2, 3, 4, and then we want to rotate list by 2, and then this is what we get, which is perfect. All right, and then what happens if we get 6, for example, because it's longer, and then we get the same thing because 6 modulate 4 equals 2, so that gives you the same thing. So if you do 0, it should not change. It should be 1, 2, 3, 4. Perfect. All right. So that's pretty much it. And I hope this was useful. And thank you so much. See you next one.